Liquidtight flexible metal conduit, or LFMC, can be used in Class 1, Division 2 locations without the need for special permission. However, it's subject to certain conditions. Firstly, it must be terminated in explosion-proof fittings. Secondly, it must not be used when subject to physical damage. Thirdly, it must be secured and supported to prevent damage. Now, let's discuss National Electrical Code, or NEC, Articles 502.4 ATWO and 503.3 ATWO. These articles apply to Class 2 and 3, Division 2 locations respectively. They state that LFMC can be used, but it must be of a type approved for the specific location. Consider Sealtite Type UA conduit. This is a liquidtight flexible metal conduit that is rated for use in Class 1, Division 2, Class 2, and Class 3 locations. Therefore, it can be used in place of rigid metal conduit in all of these locations. Based on the NEC code, Sealtite Type UA conduit can be used in Class 1, Division 2 locations without any restrictions, provided the previously noted conditions are met. It can also be used in Class 2 and Class 3, Division 2 locations, but it must be of a type approved for the specific location. It's important to ensure the specific type of LFMC is suitable for the environment and the application. When using LFMC in hazardous locations, always refer to the manufacturer's specifications and the NEC for detailed requirements. Remember to properly ground the conduit to ensure electrical safety. The use of approved fittings is crucial for maintaining the integrity of the explosion-proof enclosure. Regularly inspect the conduit for any signs of damage or deterioration. Replace any damaged conduit immediately to prevent potential hazards. Ensure that all connections are tight and secure. Follow all applicable local and national electrical codes. When in doubt, consult with a qualified electrical inspector. Proper installation and maintenance of LFMC are essential for ensuring a safe and reliable electrical system in hazardous locations. Consider the specific properties of the hazardous materials present in the location. Select LFMC that is resistant to the chemicals or other substances that may be present. Ensure that the conduit is properly sized for the current carrying capacity of the conductors. Overloading the conduit can lead to overheating and potential fire hazards. Use appropriate supports to prevent the conduit from sagging or becoming damaged. The spacing between supports should be in accordance with the NEC and the manufacturer's recommendations. Protect the conduit from mechanical damage by using guards or other protective measures. Avoid running the conduit in areas where it is likely to be exposed to impact or abrasion. When making bends in the conduit, use a conduit bender to avoid kinking or damaging the conduit. Sharp bends can restrict the flow of current and create hot spots. Seal any openings or penetrations in the conduit system to prevent the ingress of hazardous materials. Use appropriate sealing compounds or fittings. Maintain a clean and dry environment inside the conduit to prevent corrosion. Regularly inspect the conduit for signs of moisture or contamination. Implement a regular maintenance program to ensure the continued integrity of the conduit system. Keep detailed records of all inspections, repairs, and replacements. Train personnel on the proper installation, maintenance, and inspection procedures for LFMC. Provide them with the necessary tools and equipment. Emphasize the importance of safety and compliance with all applicable codes and regulations. Conduct regular audits to ensure that the installation and maintenance practices are in accordance with the established procedures. Address any deficiencies promptly and effectively. Stay up to date on the latest changes to the NEC and other relevant standards. Participate in continuing education programs to enhance your knowledge and skills. Share your knowledge and experience with others to promote a culture of safety and compliance. By following these guidelines, you can ensure the safe and reliable use of LFMC in hazardous locations. Let's delve deeper into specific aspects of LFMC installation in hazardous environments. Firstly, consider the ambient temperature. The temperature rating of the LFMC and its fittings must be suitable for the ambient temperature of the hazardous location. Exceeding the temperature rating can lead to degradation of the materials and potential failure. Secondly, pay attention to the chemical compatibility. Ensure that the LFMC and its fittings are compatible with the chemicals or substances present in the hazardous location. Incompatible materials can corrode or degrade, leading to leaks or electrical hazards. Thirdly, proper grounding and bonding are critical. The LFMC must be properly grounded and bonded to ensure a low impedance path for fault currents. This helps to prevent electrical shock and reduce the risk of ignition. Fourthly, avoid overbending the LFMC. Excessive bending can damage the conduit and reduce its flexibility. Follow the manufacturer's recommendations for minimum bend radii. Fifthly, use the correct type of fittings. Only use fittings that are specifically designed for use with LFMC in hazardous locations. These fittings are typically explosion-proof or intrinsically safe. Sixthly, ensure that all connections are tight and secure. Loose connections can create hotspots and increase the risk of ignition. Seventhly, protect the LFMC from physical damage. Use guards or other protective measures to prevent the conduit from being damaged by impact or abrasion. Eighthly, inspect the LFMC regularly. Look for signs of damage, corrosion, or wear. Replace any damaged conduit immediately. Ninthly, keep the LFMC clean and dry. Moisture and contaminants can corrode the conduit and create electrical hazards. Tenthly, follow all applicable codes and standards. The NEC and other relevant standards provide detailed requirements for the installation of LFMC in hazardous locations. Remember that proper installation and maintenance are essential for ensuring the safety of personnel and equipment in hazardous locations. In addition to the above considerations, it is also important to document all aspects of the LFMC installation. This documentation should include the following: firstly, the type and size of the LFMC. Secondly, the type and rating of the fittings. Thirdly, the grounding and bonding methods. Fourthly, the location of the LFMC. Fifthly, the date of installation. Sixthly, the name of the installer. Seventhly, any deviations from the code or standards. Eighthly, the results of inspections and tests. This documentation can be used to track the performance of the LFMC system and to identify any potential problems. It can also be used to demonstrate compliance with applicable codes and standards. Furthermore, consider the impact of vibration. In locations where vibration is present, use LFMC that is specifically designed to withstand vibration. These conduits typically have a braided outer layer that provides additional protection. Also, consider the effects of ultraviolet or UV radiation. In locations where the LFMC is exposed to sunlight, use LFMC that is UV resistant. UV radiation can degrade the plastic outer layer of some LFMC types. Moreover, consider the presence of corrosive substances. In locations where corrosive substances are present, use LFMC that is made from corrosion-resistant materials. Stainless steel and other specialty alloys are often used in these applications. The choice of LFMC material should be based on the specific chemicals and substances present in the hazardous location. Additionally, consider the potential for mechanical stress. In locations where the LFMC is subject to mechanical stress, use LFMC that is designed to withstand that stress. Some LFMC types have a reinforced inner core that provides additional strength. Also, consider the need for flexibility. LFMC is typically used in applications where flexibility is required. However, the degree of flexibility can vary depending on the type of LFMC. Choose an LFMC type that provides the necessary degree of flexibility for the application. In addition to the above, consider the cost of the LFMC. The cost of LFMC can vary depending on the type, size, and material. Balance the cost with the performance requirements of the application. Also, consider the availability of the LFMC. Some types of LFMC are more readily available than others. Ensure that the chosen LFMC type is readily available from suppliers in your area. It is crucial to have a readily available supply of LFMC for both initial installation and future maintenance or repairs. Furthermore, consider the ease of installation. Some types of LFMC are easier to install than others. Consider the skill level of the installers when choosing an LFMC type. Proper training and experience are essential for safe and reliable installation. And last but not least, consider the long-term performance of the LFMC. Choose an LFMC type that has a proven track record of long-term performance in similar applications. Consider factors such as resistance to corrosion, abrasion, and UV radiation. The longevity of the LFMC system is critical for minimizing maintenance costs and ensuring continued safety. Let's explore the specific requirements for explosion-proof fittings used with LFMC in Class 1, Division 2 hazardous locations. Firstly, the fittings must be listed for use in Class 1, Division 2 locations. Look for markings on the fittings that indicate their approval for this specific application. Secondly, the fittings must be properly sized for the LFMC. The fitting size must match the nominal diameter of the LFMC. Using mismatched fittings can compromise the explosion-proof integrity of the system. Thirdly, the fittings must be installed correctly. Follow the manufacturer's instructions carefully when installing the fittings. Over-tightening or under-tightening the fittings can damage them and compromise their performance. Fourthly, the fittings must be properly sealed. Use a suitable sealing compound to seal the threads of the fittings. This will prevent the ingress of explosive gases or vapors. Fifthly, the fittings must be inspected regularly. Look for signs of damage, corrosion, or loose connections. Replace any damaged or defective fittings immediately. Sixthly, the fittings must be properly maintained. Keep the fittings clean and dry. Remove any dirt, grease, or other contaminants that could interfere with their performance. Seventhly, the fittings must be compatible with the LFMC. Ensure that the fittings are made from materials that are compatible with the LFMC. Incompatible materials can corrode or degrade, leading to leaks or electrical hazards. Eighthly, the fittings must be suitable for the ambient temperature. The temperature rating of the fittings must be suitable for the ambient temperature of the hazardous location. Exceeding the temperature rating can lead to degradation of the materials and potential failure. Ninthly, the fittings must be resistant to corrosion. The fittings must be made from materials that are resistant to corrosion from the chemicals or substances present in the hazardous location. Tenthly, the fittings must be properly grounded. The fittings must be properly grounded to ensure a low impedance path for fault currents. This helps to prevent electrical shock and reduce the risk of ignition. Furthermore, consider the specific requirements for intrinsically safe circuits. When using LFMC in intrinsically safe circuits, use fittings that are specifically designed for intrinsically safe applications. These fittings typically have special features that limit the amount of energy that can be released in the event of a fault. Also, consider the requirements for dust ignition-proof fittings. In Class 2 hazardous locations, use fittings that are listed as dust ignition-proof. These fittings are designed to prevent the ingress of combustible dust. Moreover, consider the need for liquid-tight fittings. In locations where the LFMC is exposed to liquids, use fittings that are listed as liquid-tight. These fittings are designed to prevent the ingress of liquids which can damage the electrical conductors inside the conduit. In addition to the above, consider the use of cable glands. Cable glands are used to terminate cables in explosion-proof enclosures. When using cable glands with LFMC, ensure that the cable gland is properly sized for the LFMC. Also, ensure that the cable gland is properly sealed to prevent the ingress of explosive gases or vapors. It is essential to select and install the correct type of explosion-proof fittings for the specific application. Consult with a qualified electrical engineer or inspector to ensure that the fittings meet all applicable codes and standards. Proper installation and maintenance of explosion-proof fittings are crucial for ensuring the safety of personnel and equipment in hazardous locations. Let's move on to the support and securement requirements for LFMC in hazardous locations. Firstly, the LFMC must be supported at intervals that are consistent with its size and type. Refer to the NEC and the manufacturer's recommendations for specific support space and requirement. Secondly, the supports must be designed to withstand the weight of the LFMC and its contents. The supports must be strong enough to prevent the LFMC from sagging or becoming damaged. Thirdly, the supports must be securely fastened to the building structure. Use appropriate fasteners to ensure that the supports are firmly attached to the wall, ceiling, or other structural members. Fourthly, the supports must be corrosion resistant. The supports must be made from materials that are resistant to corrosion from the chemicals or substances present in the hazardous location. Fifthly, the supports must be properly aligned. Ensure that the supports are aligned so that the LFMC runs straight and true. Misaligned supports can create stress on the LFMC and its fittings. Sixthly, the supports must not damage the LFMC. Use supports that are designed to prevent damage to the LFMC. Avoid using sharp or abrasive supports that could cut or wear through the conduit. Seventhly, the LFMC must be secured at each termination point. Use appropriate clamps or straps to secure the LFMC to the enclosure or junction box. Eighthly, the LFMC must be protected from physical damage. Use guards or other protective measures to prevent the LFMC from being damaged by impact or abrasion. Ninthly, the supports must be accessible for inspection and maintenance. Ensure that the supports are located in areas where they can be easily inspected and maintained. Tenthly, the supports must be installed in accordance with all applicable codes and standards. Refer to the NEC and other relevant standards for specific requirements for supporting and securing LFMC in hazardous locations. Furthermore, consider the use of flexible supports. In locations where vibration is present, use flexible supports to help absorb the vibration and prevent damage to the LFMC. Also, consider the use of adjustable supports. Adjustable supports can be used to compensate for variations in the building structure or to accommodate future changes in the LFMC system. Moreover, consider the use of specialized supports for specific applications. There are a variety of specialized supports available for LFMC, such as supports for vertical runs, supports for horizontal runs, and supports for corner installations. In addition to the above, consider the use of cable ties. Cable ties can be used to bundle multiple LFMC runs together. However, it is important to use cable ties that are specifically designed for use with LFMC and that are resistant to the chemicals or substances present in the hazardous location. Proper support and securement of LFMC are essential for ensuring the safety and reliability of the electrical system in hazardous locations. Improperly supported or secured LFMC can be damaged by vibration, impact, or other factors which can lead to electrical hazards. It is essential to follow all applicable codes and standards when installing and maintaining LFMC support systems. Finally, let's address some common misconceptions about using LFMC in hazardous locations. Firstly, some people believe that LFMC can only be used in hazardous locations with special permission. This is not true. LFMC can be used in Class 1, Division 2 locations without special permission, provided that it meets the requirements of the NEC. Secondly, some people believe that LFMC is not suitable for use in corrosive environment. This is also not true. There are LFMC types that are specifically designed for use in corrosive environments. Thirdly, some people believe that LFMC is not strong enough for use in hazardous locations. This is not true either. There are LFMC types that are designed to withstand the physical stresses that are typically encountered in hazardous locations. Fourthly, some people believe that LFMC is more expensive than rigid metal conduit. This may or may not be true, depending on the specific type of LFMC and rigid metal conduit that are being compared. However, the cost of installation should also be considered. LFMC is typically easier to install than rigid metal conduit, which can offset the higher material cost. Fifthly, some people believe that LFMC is not as reliable as rigid metal conduit. This is not necessarily true. When properly installed and maintained, LFMC can be just as reliable as rigid metal conduit. Sixthly, some people believe that LFMC cannot be used in intrinsically safe circuits. This is not true. There are LFMC types that are specifically designed for use in intrinsically safe circuits. Seventhly, some people believe that LFMC cannot be used in dust ignition-proof locations. This is also not true. There are LFMC types that are listed as dust ignition-proof. Eighthly, some people believe that LFMC cannot be used in wet locations. This is also not true. There are LFMC types that are listed as liquidtight and can be used in wet locations. Ninthly, some people believe that LFMC is not as easy to ground as rigid metal conduit. This is also not necessarily true. With the proper grounding techniques, LFMC can be effectively grounded. Tenthly, some people believe that LFMC is not as readily available as rigid metal conduit. This may be true in some areas, but in general, LFMC is widely available from electrical supply distributors. In conclusion, it is important to have accurate information about the capabilities and limitations of LFMC before making a decision about whether or not to use it in a hazardous location. Consult with a qualified electrical engineer or inspector to ensure that the chosen LFMC type is appropriate for the specific application and that it is installed in accordance with all applicable codes and standards. By dispelling these misconceptions and following the proper installation and maintenance procedures, you can ensure the safe and reliable use of LFMC in hazardous locations.